All right, let's dive right into one of the biggest, most mind-bending questions in all of physics. Is our three-dimensional universe, the very fabric of space-time that you and I live in, just an elaborate illusion? Like a projection from a flatter, simpler reality? Now, this incredible statement, it isn't science fiction. It's actually a leading idea from the absolute frontier of theoretical physics. The suggestion here is that everything we see, space, time, even gravity, isn't fundamental at all. It's built from something much deeper, much weirder, the bizarre connections of quantum information. So, to really get our heads around this, here's our game plan. First, we'll look at why physicists even need an idea this wild. Then, we'll explore the tale of two universes that makes it all possible. We'll see how space-time could literally be woven from quantum threads, but we'll also hit the brakes and look at the theory's problems. And finally, we'll ask what this all means for reality itself. Okay, let's kick things off with the big problem. The reason brilliant minds are even entertaining such a radical idea. It's all about uniting the two great pillars of modern physics. See, on one hand, you have Einstein's general relativity. It's beautiful, it perfectly describes gravities, stars, galaxies, the whole cosmic shebang. On the other hand, you have quantum mechanics, which is just flawless at describing the tiny world of atoms and particles. The issue? They are completely, fundamentally incompatible. They just don't speak the same language. And when you get to places where they have to meet, like inside a black hole, the math just breaks. It's a total mess. We need a new theory, a theory of everything, to bridge this enormous gap. And this is where things get really interesting. This brings us to a groundbreaking idea proposed back in 1997 by a physicist named Juan Maldacena. It's called the ADS/CFT correspondence, and it's basically our first real tangible clue about how these two worlds might finally connect. Okay, I know, that is a total mouthful, but the core idea is absolutely stunning. What Maldacena found was that two completely different-looking universes are actually mathematically identical. It's like having two different languages that can describe the exact same story perfectly. One of these universes has gravity, and the other one doesn't, and yet they're just perfect translations of each other. So here's where the hologram analogy really clicks. Imagine you have this higher dimensional world, which physicists call the bulk. That's the one with gravity. Then you have its lower dimensional boundary, which is a totally flat world of quantum particles, no gravity in sight. The theory says that everything happening inside that gravitational bulk is just a projection, a holographic image of all the quantum stuff happening on the flat boundary. It's literally a dictionary between a world with gravity and a world without it. So, if the bulk is just a projection of the boundary, what does that say about space-time itself? I mean, really think about that. This is where the theory goes from being clever to being truly reality-shattering. Here it is, the core insight. The very fabric of space isn't fundamental. It's something that emerges. The smooth, continuous reality we all experience is actually woven together by quantum connections on that boundary. And specifically, it's woven from the super strange quantum property called entanglement. Where two particles can be mysteriously linked no matter how far apart they are. And listen, this isn't just some philosophical hand-waving. There's hard math here. This formula is a key page in that dictionary we were talking about. It gives us a precise recipe to calculate a property of gravity inside the bulk just by measuring the amount of quantum entanglement on the outside boundary. It's a direct link. The more entanglement you have on the boundary, the more space you get in the bulk. It's incredible. And that idea takes us to the next level. This concept, summarized as ER equals EPR, suggests something truly wild. Imagine you take two particles on that flat boundary and you entangle them. According to this holographic dictionary, the gravitational picture of that quantum link is a wormhole, a literal geometric bridge through space-time connecting their locations inside the bulk. So how does this actually build reality? Well, you start with something that's pure information, a quantum link on the boundary. That link gets projected into the bulk as a real, physical, geometric structure, a shortcut through space-time. The mind-blowing takeaway here is that the connection in space literally is the quantum entanglement. Geometry, space itself, is built from information. Now, before we all get way too carried away and decide we're living in the Matrix, we have to pump the brakes and inject a serious dose of reality here. As beautiful and elegant as this theory is, it comes with some major caveats. This isn't a description of our universe, at least not yet. For one,
This whole correspondence works perfectly in a very specific kind of toy universe called anti-de Sitter space. It has this weird, saddle-like negative curvature. But our universe, from everything we can see, seems to be either flat or have a slight positive curvature. And that's not a small detail. It's a huge obstacle. Figuring out how to make this holographic dictionary work for a realistic universe like ours is one of the biggest unsolved problems in physics today. So while it's an amazing theoretical tool, it's still a model of a universe, not necessarily our own.
But let's just imagine for a second. Let's say they solve those problems. What would it actually mean if our universe really is a hologram? Well, the implications would completely rewrite our understanding of reality from the ground up.
The things we take for granted, right? That a cause has to happen before its effect, or that an object has a definite location in space. These might not be fundamental rules of the universe at all. They could just be features of the holographic projection, shadows on the wall. The true reality would be the quantum bits on the boundary, playing by a completely different and much stranger set of rules. Our entire physical world would be the illusion.
And that leaves us with this final, provocative thought. If spacetime is built from quantum information, maybe the universe is, in essence, a giant quantum computer. And the laws of physics that we study? They might be nothing more than a kind of quantum error correction code, just a process that makes sure the holographic projection stays stable and consistent. It suggests that at the deepest, most fundamental level, reality isn't made of matter or energy, but of pure information.